All right, let's just dive right into this explainer. Today, we're cracking open the programmer's toolbox to tackle Chapter 10, which is all about two absolutely foundational ways to store data in Python: tuples and dictionaries. You already know that efficiently managing data is like half the battle in coding. So we're going to look at two totally different structures today, one built for unbreakable security and the other for infinite adaptability. You know, coding really is an art form. The visionary Alan Kay famously said that computers are to computing as instruments are to music, and software is the score. I just love that analogy. Today, we're basically learning how to play two entirely new instruments in our Python orchestra. Getting this right is what allows us to write much more elegant, powerful software. Okay, real quick, here's our syllabus for today's explainer. 1. Welcome to Chapter 10. 2. Tuples, the immutable sequence. 3. Mastering tuple operations. 4. Dictionaries, key-value mapping. And 5. Manipulating dictionary data. Section 2. Tuples, the immutable sequence. All right, so let's start with our first tool. Honestly, the best way to think about a tuple is like a secure, unchangeable lockbox for your data. Once you pack it and snap that lid shut, the contents are completely set. So what exactly is it? Well, a tuple is an ordered sequence. And what's cool is it can hold elements of completely different data types. We're talking integers, floats, strings, lists, or hey, even another tuple packed inside it. You just enclose these elements in parentheses and separate them with commas. But here is the absolute most crucial point. It is immutable. Once you create a tuple, those contents are locked in. You literally cannot change them. It's a structure built entirely for safety and predictability. Now, this right here illustrates a classic beginner pitfall from the chapter. Let's say you want to create a tuple with just a single element, right? Like the number 20. If you just write 20 inside parentheses, well, Python doesn't actually create a tuple. It just sees a plain old integer. To do it the correct way, you absolutely must include a trailing comma. That tiny little comma is the exact signal Python needs to construct the sequence. Remember how we talked about immutability? Well, here's what happens if you try to fight it. If you take a tuple and try to force a change, say updating index 4 to the number 10, Python will literally throw a type error at you. It actively protects your data, making sure that whatever you put in that lockbox stays exactly the way you left it. No accidental overrides here. Section 3, Mastering Tuple Operations. Now, even though these lockboxes are securely shut, there is still a massive amount of manipulation we can do. Just because we can't change the internal elements doesn't mean we can't analyze them, combine them, or slice them up. Here's a super handy cheat sheet of built-in functions for analyzing that locked-in data. You've got the length function to check how many elements there are, and count to see how frequently a specific element pops up. Need to find where an item is? The index method gives you the exact location. And what about sorted? Since we can't change the tuple itself, sorted simply takes the elements and hands you back a brand new sorted list, leaving your original tuple completely untouched. Oh, and of course, min and max are right there to help you quickly crunch numbers. Let's talk about unpacking, because this is a massively useful feature. Python lets you elegantly assign multiple variables at once from a single tuple. Say we have a record containing a student's name, their roll number, and their subject. We can assign all of that to the variables name, roll number, and subject in one single line of code. It's so clean. The only catch? The number of variables on the left side of the equal sign has to exactly match the number of elements in your tuple on the right. Plus, we can interact with tuples a lot like we do with strings. We can concatenate them using the plus symbol, which just creates a brand new longer tuple. We can repeat their contents using the asterisk. Want to check if specific data exists in there? Just use the in or not in operators for quick true or false. And naturally, we can use the standard slicing syntax, start, stop, and step, to extract specific segments without disturbing the rest of the sequence. Section 4. Dictionaries, key-value mapping. Okay, let's put away the unchangeable lockbox for a minute and pull out tool number 2. Think of this one as your dynamic filing cabinet. Welcome to the world of dictionaries. So unlike tuples, which rely on numbered sequential indexes starting at 0, a dictionary uses unique keys to store and look up data. Picture these keys as the labels on a file folder. It's basically a mapping between a set of unique keys and a set of values, all wrapped up snugly in curly braces. The rule of thumb here is that the keys must be unique and they have to be an immutable data type, like a number, a string, or actually a tuple. The values, on the other hand, they can be anything you want and they can absolutely be repeated. Let's look at a dictionary in action. Notice those curly braces on the outside. Inside, we've got key-value pairs separated by commas, with each individual pair connected by a colon. In this setup, we're perfectly pairing a student's name as the unique key, like Mohan or Ram, with their percentage as the value. It's incredibly readable. And because we set up these neat little labels, retrieving data is, well, it's just super intuitive. Instead of trying to remember, oh, was Ram's score at index position 1 or 2, we simply ask the dictionary for the value associated with the key Ram, using square brackets. Bam! It instantly returns 89.
Section 5, Manipulating Dictionary Data. Because dictionaries are mutable, they're designed from the ground up to be changed, updated, and expanded on the fly.
This means you can add a brand new student to your system using that exact same simple bracket syntax. By declaring the dictionary key Meena equals 78, Python simply drops a new folder for Meena right into the cabinet. Need to correct a grade? Same syntax. Overwriting Suhel's score with 93.5 is completely seamless. Oh, and just like with tuples, you can use the in operator here too. But keep in mind, it specifically checks if a key is present in the dictionary, not a value. Now, when you need to read through the entire filing cabinet, you traverse it. Using a simple for loop lets you walk through the dictionary step by step. First, it extracts a key, then, inside the loop, you use that key to access the corresponding value. This gives you a really beautiful systematic way to print out all your mapped data, like Mohan 95, Ram 89, and so on. Naturally, just like our first tool, dictionaries come packed with their own powerful set of built-in methods, giving you total control. Need a list of just the labels? Call the keys method. Need just the grades? Call values. I personally love the items method because it returns a list of both, perfectly packaged together as tuples. You can even smash a second dictionary onto your current one using the update method, or just completely wipe the slate clean with the delete command or the clear method. So here's the real question. When architecting your next program, will you choose the unbreakable security of a tuple or the infinite adaptability of a dictionary? Understanding exactly how and when to deploy these two incredible instruments will absolutely transform the way you write code. Got configuration data that absolutely must not change during runtime? Lock it down in a tuple. Dealing with a constantly shifting registry of users and scores? That is 100% a job for the dynamic flexibility of a dictionary. Thanks so much for joining me on this explainer of Chapter 10, and I'll catch you next time as we keep building out our programmer's toolbox.